When you reach, I'm going to start when you reach 30, you are still 16. I'm going to start when you reach 30. I don't want to repeat myself. When you reach 30, we are going to start the lesson. Use my book. Number 12, use my book. You can use my book. I'm just going to continue from where I stopped from school.
Teacher, which book? Numerical methods, probability.
Probability book is probability. Discrete random variables is under probability. So we are going to start. Get ready, get organized. Yes, probability book. Now we start. So our topic today is discrete random variables. Good morning once again.
Good morning.
There are basically three words. We have the word discrete, random, and the word variables. They are all English words. As other people are joining, they're going to first understanding the meaning of these words and expect you to contribute. I am very sure that some of you have some ideas or you know. But I'm also going to assume that not all of us know this topic. Nabwami Halwa, can you please mute? Nabwami, let me mute you. Okay, good. I'm going to assume that some of us, okay, I'm not assuming, but I know that some of us know and others don't know. But I'm going to move at the pace of those who don't know, who have never studied this topic. Is it okay? I expect those who have done some work in discrete random variables to contribute. That's why I want to make it a student-centered lesson, though it is online, but can still be student-centered. Feel free to contribute when I ask a question. Okay, we're going to first look at some of the definitions that when we measure these ones in the questions, you'll be able to understand. This probability involves reasoning, and therefore you can reason better if you understand a certain word properly, a concept used. Let us, the first subheading is definition of key terms. First underline your heading, definition of key terms. Definition of key terms. Our first key term is a variable. What is a variable? Who can define for us? We are still 50, almost at the number, but we can proceed. What is a variable? That is our first term. A variable. Feel free to contribute. Variable. It's just an English word, please. A variable. Divine, do you have any idea? When you hear that word variable, what does it mean? Okay, while failing to contribute. Okay, for this one, let me also contribute first. A variable is a quantity whose value changes. A variable is a quantity whose value changes. Variable is a quantity. Variable is a quantity whose value changes. Variable is a quantity whose value changes. Hey, let me see. I think I should not write here. Variable is a quantity whose value changes. Whose value changes. I think you can see very well now. A variable is a quantity whose value changes. Anything that varies is a variable. That's just an English word. Now, what is a discrete variable? The next definition. Discrete variable. Discrete variable. Discrete variable. I'd like to advise you, dear students, that during the lesson, it is better to contribute if you know. When you share, you learn. When you share, when you give, you receive more. When you share what you have, you receive more. You gain more. You retain a lot. You never forget what you have contributed in class. What is a discrete variable? What is a discrete variable? Rebecca Agutu. Discrete variable. Am I talking to the ladies of Navisonsa girls? Or because of COVID?
Teacher.
Sandra, what is a discrete variable? Can you try, please? Just mention what you know, how you understand that word. Discrete variable. If someone mentioned this, what is a discrete variable?
Teacher.
Yes, please.
Maybe it is a value obtained by counting.
Very wonderful, you're a smart girl. A discrete variable is one whose value is obtained by counting. A discrete variable is one whose value is obtained by counting. Whose value is obtained by counting. That's a discrete variable. Hey, let me see. Oh, discrete here, people cannot see. Let me write it up here. Let me write the heading up. Discrete random variables. Don't be going late, sorry. Discrete random variables. Discrete random variables. That was our heading. Random variables. Discrete random variables. We have started by defining the key terms so that you can clearly understand all the terms we are going to be using in this topic of random variables. I want to remind you that we have two types of random variables, discrete and continuous. But today, we are going to first handle discrete random variables and their properties and the mathematics of these discrete random variables. Therefore, we must know what we are going to handle. Therefore, we started by defining the key variable, the keywords. And our first word was a variable. And we noted that a variable is a quantity whose value changes. The next one was discrete variable. Someone contributed that a discrete variable is one whose value is obtained by counting. The second one was discrete variable. Discrete variable. Discrete variable. Noted that a discrete variable is one whose value is obtained by counting. Is obtained by counting. Therefore, I'm also sure that you can now give me examples, some examples of discrete variables. After knowing the meaning of the word variable, any quantity that varies, any quantity whose value changes, your age, your height is a variable. Your age keeps on changing every after a minute, but it may not be discrete. We shall categorize these variables, but we are starting with discrete variables. The number of students attending, every minute people are joining the lesson. The number of students attending this lesson is changing. It is changing, and therefore the number of students in this lesson is a discrete variable. Attending the lesson. Can you give me some examples? Examples of discrete variables. Examples of discrete variables. Some examples, just give some. You may not exhaust all. Some examples of discrete variables. discrete variables. I've already given some. I want you to add on the list. Some examples of discrete variables, Nachitende Mariam. Since you are not sure, I'll bring that one up. The first thing about those examples, because you don't want to contribute. Let us look at another definition. Can you first give me examples before we go to another definition? Give me an example, just feel free.
Teacher Shu says.
Okay. Okay, let us look at another term if you are not sure. What about random variable? Random, we have added in the word random. The words we have in our topic, discrete random variable. We have defined a variable, we have defined a discrete variable. We are going to add on the word random. Random variable. Random variable. Then you'll be able to give me examples. Random variable. Yes. Anyone who has an idea? Random variable. When you mention random variable, what does it mean? If you say that, if you mention that word random variable, what does it mean? What is a random variable?
It means probability function.
Probability function. Okay, you have tried. Probability function is just a function used to generate probabilities. That is the meaning of probability function. Any function, a probability function belongs to the family of functions. Only difference with it, it is for this a special function used to generate probabilities. That's why it's called a probability function. But it can be a probability function of a discrete random variable, it can be a probability function of a continuous random variable. Now, our interest here is the meaning of a random variable. Random variable. But you have tried, let us proceed. Random variable is one whose value is a numerical outcome of a random phenomenon. Random variable is one whose value is a numerical outcome. I think I should write it. Random variable. Random variable is one whose value is a numerical outcome of a random phenomenon. Random phenomenon. A random variable is one whose value is a numerical outcome of a random phenomenon. Random phenomenon. That one is an English word. That one I'm giving it to you as an assignment. Find out the meaning of the word phenomenon. Phenomenon, that one you're not going to find it, dear ladies. I'm going to move this. Let me go back to examples. Now that I've given you time to think about them, I expect 2 or 3, then you proceed to the mathematics of discrete random variables. Some examples 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 of discrete random. Here you're listening properly. Variables. Yes, list some. People have messages. The number is increasing. The number of students attending this lesson is a variable because the number keeps on increasing. You want to find out, is it random variable? Is it random? That's what you want to know. Some examples of discrete random variables. Yes, Lee? This is my neighbor here. Give us. Okay, they're not able to hear. Let me pick from here. Maren Sima. Give us at least one. From the so many examples. We have endless, infinite number. We cannot exhaust all. That's why we're going to just list some examples of discrete random variables. What we are doing now is more important than the mathematics. Some of you like cram work. You like just calculating what you don't know. And yet, this is applied math. We must understand whatever we are doing. When I mention a certain word, it is important that you know what it means. Don't simply calculate what you don't know. Yes, am I talking? Am I clear?
Yes, teacher.
Okay, now I'm telling you to give me examples. Please try to be fast. I expect you to contribute. I always prepare a learner-centered lesson. I would have just written this, and then by now I would have done like 5 examples. Okay, now that you don't want to contribute.
Is an example, let me say, number of chairs or number of cars, because you said you just opened by counting.
Okay, good.
Yes, teacher.
Edwin, you are a smart girl. Okay. The number, can you repeat for your colleagues, Edwin?
Teacher, I've said that there's an example, I think, is number of chairs, number of cars, because we obtain them by counting.
Okay. Number of chairs in a classroom. You can get the number of chairs in a classroom by counting 1, 2, 3. You can even start from 0. You might find an empty classroom without any chair. Even 0 is a value. The number of students in a room, in a classroom, can be obtained by counting. Therefore, it is a discrete variable. So some examples of discrete random variables, we have number of children in a family. Number of children in a family. You can obtain the number by counting. Number of COVID-19 patients in a hospital. Number of
Teacher, but that's a variable.
Yes?
Teacher, isn't that a variable? Isn't that a variable?
It's variable, discrete. We can count, but up to infinity. As long as you obtain that number by counting. The number can be 1 million, 10 million, 100 million. Any number, any value that is obtained by counting is discrete. Okay, now, the number of girls in a family of 4 children. The number of girls in a family of 4 children. Okay, let us first complete this. The number of girls in a family of 4 children. Now, this one, since I've specified in a family of 4 children, we are giving some examples. The number of girls in a family of 4 children. Now here, these are being specific. The number of girls in a family of 4 children. What are the possible values? that this one can take on. Let us list down the possible values. Possible values. Possible values here for this discrete random variable. The number of girls in a family of 4 children. The possible values are. Yes, please. Contribute. Yes, please.
Teacher, someone has given an example of weight of a person, but then I'm asking weight of a person. Can it be acquired by counting?
No, that one's not correct. Weight of a person is continuous. So it cannot be collected by counting, but by measuring. We shall look at that second type of variable, which
but
is
it's a variable.
It is a variable. It's a variable, good, but it is continuous, not discrete. Because you cannot obtain weight by counting. You cannot obtain weight by measuring.
Okay.
Your age is continuous.
Okay.
It is a variable, but not discrete. It cannot be obtained by counting. But you can, your age keeps on changing every after second. We are first now specializing. We are going to look at first discrete random variables and the mathematics of discrete random variables. But we should also understand the meaning of continuous. Don't confuse the two, but we shall look at continuous random variables in its own. Have I answered your question?
Yes, teacher. Thank you.
Okay. Possible values. Back to our some examples. We are now looking at some examples of discrete random variables. And the last one we had looked at was the number of girls in a family of 4 children. We are going to look at the possible values this random variable can take on. The random variable is any value that changes, any quantity that keeps on changing. If it's obtained by counting, then it's a discrete variable. Any quantity whose value changes is a variable. We have 2 types of variables. Don't write this, but just understand this: discrete and continuous. We are looking at discrete now. We have looked at the meaning of a variable, meaning of a random variable, the meaning of a discrete variable, and therefore a discrete random variable. We now understand the meaning of a discrete random variable. We have combined all the words, all the terms in our topic. We are giving examples of discrete random variables. We have listed many, and now we are looking at the number of girls in the family of 4 children, and we are now listing the possible values for this random variable. When you have a family of 4 children, what is the possible number of girls in that family? Okay, since you're keeping quiet, let me give the first one. It's possible to have 0 number of girls. I've given the first one. When you have a family of 4 children, you can have 2, but let us move in order. You can have 1 good. Now I'm sure you have understood. Up to 4. You can have 0 number of girls. You can have 1 girl. You can have 2 girls. You can have 3. The children can be girls. So therefore, our random variable can take on those values: 0, 1, 2, 3, 4. But how do you know that it's 0? You can count, you can see, go to the family, they find only boys. So the number of girls you have is 0. Go to the family, they find only 1 girl, you obtain that by counting. You find 2 girls, the rest are boys, you count. How do you know that these are, how do you determine the 2 girls? By counting BTC. Lastly, the number of effective light bulbs in a box of 6. The number of defective light bulbs in a box of 6. The number of defective light bulbs in a box of 6. So I would like someone to contribute. Give me the possible values. You know what I mean? Some of you offer physics. You offer also physics in all levels. When I talk about defective, non-defective. Yes, some of you are here. sending funny messages. If someone missed yesterday, can you first concentrate in the lesson? Auma. I expect to send a message connected to what we are doing. Not
Yes, teacher.
Yes, please. Yes, I'm hearing. Yes, please. Hey, the question has disappeared. Okay.
Teacher.
The number. Yes, yes, please.
Maybe you can have 0 defective bulbs in a box of 6, 1, 2, 3, and 4.
So
And 5,
number,
all of them are defective.
Okay, you can have 0, 1, 2, 3, 4, 5, up to 6. It is possible to have 0 defective bulbs, or 1, or 2, or 3, or 4, or 5, or 6. All of them may be defective. That is 6. Good. You are smart girls. I want you to note others. You can list. The list is endless. Okay, we proceed to. I want us to note something here. Now that we know what we are doing, we're going to increase on the speed, but not at the expense of understanding. Okay, note the following. Note the following. Random variable is noted with a capital letter. Random variable. Some of you make this mistake. Random variable is noted with a capital letter. Noted with a capital letter. So math is the language, like English. When I write a sentence and put a full stop at the end of the sentence, means that is the end of a sentence. When you write a variable and you start writing smaller letter, then you don't know what you're talking about, what you're writing. Random variable is represented by capital letter. But this one you're not going to write. But the values the random variable takes on, they are represented by a small letter. For example, if X is the number of girls in a family of 4 children, the number of girls can be 0, 1. Now this 0, 1, 2, 3, 4, up to 4, they are represented by X. That's why we normally write this probability of X in that form. This capital X takes on values, certain values. Random variable X takes on those different values. And those different values can vary, keep on changing. Okay, our point of interest here is that random variable is noted with a capital letter. You can use any capital letter. We prefer using X in math. But don't be surprised when you find a different letter, Z, there are other letters that can be used. But we mainly use, most people prefer X. Okay, that one should be noted. Next, discrete probability distribution. Discrete probability. Discrete probability. Someone is asking discrete probability distribution. I should write somewhere distribution. Are you seeing here? Let's see. Discrete probability distribution. Discrete probability distribution. Discrete probability distribution. Sabra, you are failing to join. We put in class. Okay. You are now 100. What is a discrete probability distribution? That's our next term. Want to understand our subheading, next subheading. Okay. Anyone, any volunteer, anyone to contribute about that? A discrete Okay, discrete probability distribution. Discrete probability distribution. Discrete probability distribution. People, you don't want to contribute, you don't like contributing. And this is a table of formula listing. This is a table of formula listing all possible values that a discrete variable can take on together with the associated probabilities. This is a table, right? This is a table. This is a table of formula listing all possible values that the discrete variable, you see all these words we have defined them, listing all possible values that a discrete variable is what you can just add the word random variable. Discrete variable can take on together with the associated probabilities, together with the associated probabilities. Together with the associated probabilities. I want to give a simple example of discrete probability distribution. Feel free to ask if you have not understood any term before we start on the mathematics of random variable, discrete random variables. This is a simple example of a discrete probability distribution. That random variable can take on values, small x, and there are probabilities that the random variable takes on those specific values. I'm just going to assume that if the random variable takes on value 0, the probability of that variable taking on value 0 is 0.3. If the probability takes on value 1 is 0.1, probability takes on value 2, 0.3, value 3, 0.2, and finally value 4 is. If I connect this the number of girls in a family of 4 children, it means that there is a probability that we have no girl in a family of 4 children. That probability is 0.3. The probability to have only 1 girl is 0.1. The probability to have only 2 girls is 0.3. And the probability to have only 3 girls is 0.2. And the probability that all of them are girls, that is 0.1. That's an example of probability distribution. I want you to understand this also in this form. Some of us are used to a frequency distribution of max. They tell you to draw a frequency distribution. You are given ungrouped data, and you are required to form a frequency distribution. That means you have, if it is for, you can have a mark. If the data is not big, if the max, you have very max maybe for around 20 students or 10, you can list the mark and number of times it appears. 50 appears how many times? 70 appears how many times? 8 appears, though we prefer listing order from the smallest to. Now that's the frequency distribution. The max and the number of times appear. The number of times is what we call the frequency. The number of times an item occurs is what we refer to as a frequency. And therefore, we can end up with a frequency distribution of max. The same way you can have a probability distribution, which we have defined the table of formula, listing all possible values that a discrete variable can take on, together with associated probabilities. You can proceed. You can proceed. Think about others.
Excuse me, teacher.
Yes, please. Yes,
What
I'm
does
here.
the X, that's the small X, what does it mean? What
Yeah.
does it symbolize, that small X?
That small x?
Yes.
I've just mentioned it, isn't it? Okay, who can help us tell us why do you write a small x and somewhere write capital X? I mentioned it somewhere. Maybe our friend was not in class, or she had gone for tea. I had mentioned it.
You said
That is the
you
desire.
had given us you had given us an example of number of girls in a family of 4 children.
That is
So when we
very-
listed that, yes. So when we listed the possible values, that was 0, 1, 2, 3, and 4. You said that those are the small x's.
Wonderful.
Then when we random variable, you told us it's represented by a capital letter, which is normally capital X.
Yes, very good, you're a smart girl. Now, the values that a random variable can take on, they are represented by a small letter. For example, we gave this example, specific example of the number of girls in the family of 4 children. Number of girls in the family of 4 children is a discrete random variable. Discrete, because obtained by counting, you should know why it is random, but it takes on different values. Because we noted from the beginning, when we are looking at our definitions, we noted something about a variable. I was not wasting my time to give those definitions, by the way. We noted that a variable is a quantity whose value changes. Now, the number of children in a family of 4 girls can be 0. That small x can take on value 0. Okay, can be 0. Now, the random variable x can take on the value 0. But that 0 is represented by a small letter. Where there is 0, you can write x is equal to 0. Let me write it here, so that you can see. Our friend asked a question. I can write that probability that x is equal to 0 is 0.3. Probability that x is equal to 1 is 0.1. This one here, you see 0 is now representing the small x. X equal to 1 is representing the small x. It sits in the place of small x. X is equal to 3, sits in the place of small x. Have I answered your question? The one who asked the question.
Yes.
Yes, please. Perfect. Say yes or no.
Yes, you have.
Okay, very good.
So teacher,
Yes.
in simple terms, according to that table that you have drawn, in a
Yes.
family, if there are 0 girls, the probability is 0.3. Is it how you can put it in simple terms?
Very wonderful. You are a good girl. You're a smart girl. Now, okay, like the way you have said, sometimes we can give in this form. Alternatively, this one can be written like this. X is equal to 0. The probability that x is equal to 0 is 0.3. The probability that x is equal to 1 is 0.1. You see, when you are teaching bright students, you can enjoy the lesson. 0.3. The probability that etc. the story continues, but I can list them because they are not many. They are not many. So, but there's something we are going to note here as we look at the properties of a probability distribution. There are some properties we're going to analyze here. So this one exactly, as someone has said that briefly, in simple terms, it means this, means that, in simple terms. But we don't have hard terms here. We don't have hard terms. All of them are simple terms, as you have said. In simple terms, I think I can remove this because you have already written it in simple terms. Now,
Teacher,
yes, please.
how did you find those probabilities?
I assumed. That's what I mentioned first. Now we are going to find a way. Okay, the next part we are going to look at is how to generate a probability distribution. How do we generate a probability distribution? Now here, in the first example, I can assume that you are bright. When I don't have evidence that you are bright, I've assumed certain values. The number of girls in a family of 4 children, you say it can be 0, and I've assumed the probability. The chance of having no girl in a family, in a certain family in the village, you can find a very high chance of 0. Not very high, but because 0.3 is not high, but the probability of 0.3. So those are just assumed values. So don't think about them. But when I'm thinking, of course, there's something I put in consideration when I'm thinking about these probabilities, as you are going to see. When you add all those probabilities, they will give me something which I'm not going to mention, but we shall find out what is that. And now the probability distribution can also be, as from our definition, discrete probability distribution. This is a table or formula listing all possible values that a discrete variable can take on together with the associated probabilities. And we have given an hypothetical example. Now, but we can also write this as a probability function. Someone mentioned as instead of drawing a table, you can represent probability distribution in the form of a function. It can be represented by a function, a probability function. So therefore we can say, oh, as a probability function, probability function, I want you to understand this, because even at the university, there's no course without probability for your information. In medicine, you do biostatistics. In economics, business, you do business statistics. In all courses in education, you also do statistics. Education psychology has statistics. It is everywhere there is statistics. Statistics is a living subject. Okay. Now, as a probability function, we can write in this form the probability of x. This one, read this one as probability of x in simple terms. Probability of x. You may not read this as probability of x equal to small x. No, in simple terms, read this as probability of x. Probability of x. So, and therefore, you can write this one. This is also, I've just picked the function of that form. And this function, the values of x can take on these values from that function. 0, 1, 2, 3, up to 4. Now, what does it mean here? The probability x equal to 1, x equal to 0, we put a 0 here, that will be 0. The probability x equal to 1, put the 1 here, that would be k. Now, this is a function used to generate probabilities. Up to 4, beyond the 4 and below 0, the probability will not exist in this 0. The probability of an impossible event is always 0. Remember from the beginning of probability, we noted that probability can take on any value from 0 up to 1. When the event is impossible, cannot occur, the probability of that occurring is 0. Now here, if this random variable takes on values 0, 1, 2, 3, up to 4, when it is 5, it will be the probability of x equal to 5 will be 0. That's why we are writing kx, x taking on value 0, 1, 2, 3, up to 4, and 0. Otherwise, you normally use the word otherwise. That's what it means. That when x is equal to -1, the probability will be 0. But also we can also write in this form, or you can use small f(x), small, not capital. I want you to understand this. K over x, no x, I'm going to use x over k. For values of x, I'm starting from 1. I can also start from 0 by 1. And I'm deciding to start from. And sometimes we use elsewhere. Elsewhere. How do you spell elsewhere? That's how we spell it. Elsewhere. Okay, you can proceed. Now that you know what you are looking at, someone asked, how do we get those probabilities? We are going to look at this one here. This is how we generate. Don't have trouble. Okay, right, very fast. Suppose you want to look at more examples, then I'll give you what? When you delay, I'll give you out of what? I'm sure you have finished this, isn't it? Who has a constant? I think this is, let me read for you this. Probability of x equal to kx. K is a constant. K is a constant. X over k. K is a constant. For values of x from 1, 2, 3, 4, 5. Values of x is from 0, 1, 2, 3. Now, from this form, from this can also be simplified further. Now, these are probability functions. Probability functions. Okay. I wish I had the. Okay, let me first remove this so you can put this on the side. My board is small. Now, this one here can also be from that form when you are working out these ones and just doing the mathematics of random variables. You always first prefer putting it in this form. The table form, before we proceed, 0 is better. When it is 0, put 0 here, you have 0. When it is 1, put 1 here, you have k. When it is 2, put 2 here, you have 2k. 3, you have 3k. 4, you have 4k. Now, this one brings out the concept of the probability distribution series. A table listing all the values the random variable can take on together with their associated probabilities. But this time, the probabilities in terms of k. The same applies to the second one, written also in this form. That is your take home. The second one, the second function, also write it in that form. And then you proceed. Now let us look at examples. The examples of how we can generate a probability distribution. Examples of how to generate probability distribution. So I'm removing. Let me see the time left. Yeah, we have around 28 minutes left. Since we are coming to the end of the lesson, the last 30 minutes, we are going to increase the speed. And now that we know what we are talking about, that is going to be easy. We are going to be able to be fast. No, we have only 33 minutes left. Examples. One, the box contains 3 red and 2 green. The box contains 3 red and 2 green cards. 2 cards are removed. 2 cards are removed from it. One at a time, without replacement. Construct the probability. Construct the probability distribution. Construct the probability distribution table. Construct the probability distribution table. Sometimes you add that word, table. Construct the probability distribution table for the number of red cards removed. So next time I'll just Just come with the soft copy and just share the screen for those numbers. I think save time. You'll not be writing those questions. I'll just share the screen and you write. Okay, now that is write very fast and proceed. So have you finished writing the question? I want to move. Yes, please.
Not yet, teacher.
Okay, be fast because our board is small. Okay, let me ask. Okay, I think we have finished. Let me just see. Okay, I'm removing this. Meanwhile, think about it. And then think about that solution. Okay. Yeah, you have the question. So we have our box contains 3 red, 2 green. 3 red, 2 green. We are supposed to pick 2 cards at random, one at a time without replacement. And also, yes, we are expected to generate a probability distribution for the number of red cards removed. Since we know the meaning of probability distribution, it must be a table listing all the possible values the random variable can talk on, together with the associated probabilities. We are going to list down all the possible end results of this experiment, which we call the sample space. Now, it is possible that in the first picking, you can pick red. The first card can be red, and the probability of that card being red, the first one being red, is automatically 3 out of 5. Or the first card can be green, and this one is going to be 2 out of 5. Because of time, I'm going to increase on the speed. Now, if the first one was red, it's also possible that the second card is red. Now, the probability here is the probability that the second is red, given that the first is red. You didn't replace, it means the number of red will be 2 and the total will be 4. Automatically, this one is also going to be 2 out of 4. And this one, this total of 4 represents the probability that the second card is green, given that the first one was red. The same applies in the same way. You'll fill this tree beside in that same way. the probability that the second one is red, given that the first one was green, will still be 1 out of 4. No, it will be not 1 out of 4. I'm going to first use this. It will be 1 out of 4 here. Automatically, this one is going to be 3 out of 4. So it's always better to first fill these probabilities along branches of the same color, cards of the same color, green, green, red, red, etc. Now, what are the possible end results here? It is possible to have red followed by red, red followed by green, green followed by red, green followed by green. These are the possible end results of that experiment. Now, what is our interest here? The number of red cards. The number of red cards. Number of red cards. Are you able to see here? Number of red cards. Of red cards. Number of red cards. Red cards. That number, we're going to present it by X. Number of red cards, that's the random variable. Construct probability distribution table for the number of red cards removed. The number of red cards removed here is 2. If the first card is red, the second is also red. Those are 2 cards. It's possible to have 2 red cards. All of them are red. It's possible to have red followed by green. That is 1. Here, it is 1 and 0 red cards when both are green. Now let us generate their associated probabilities. Since X represents the number of red cards removed, the probability, I'm going to start with the smallest, that you have 0 red cards. Will be represented by the probability of having the green card followed by the green card. All of them are green and therefore have 0 red. How do we get the probability here? For this end result, just multiply probabilities along the branches. This one is going to be 2 out of 5. That is a quarter. I'm not going to reduce, I'm going to leave it in that form. I'm going to remove this and compute the probabilities, all the probabilities here. Okay, the space is not enough.
Teacher, first wait, teacher.
Okay. I thought I was very slow. Sorry, ladies. The probability that X equal to 0, that don't have a red card, it means that the first card was green and the second was green. And obtaining that probability for this end result, you multiply these probabilities along the branches. Can you please increase on your speed? And that is 2 out of 20, which is 1 over 10 if you want. But I want to leave, there's a reason why I want to leave it in that form. Okay. Now the board is small and someone is telling me not to move. Okay, let me write here. For the second one, the probability we shall adjust next time because we use the smaller board. Next time we shall adjust and be able to use a bigger board. Okay. Sorry for the inconvenience caused. That's why you should try to be fast. I'm going to write up here. The probability that the random variable, that the number of red cards, that you have only 1 red card, that probability will be equal to the sum of these 2 probabilities. The probability of having red followed by green, or Okay, plus the probability of having green followed by red. Also want to explain this concept clearly. When I write probability of R1 followed by D2 or D1, it means this or that.
Excuse me, teacher.
Yes, please.
Excuse me, teacher.
Yes, I'm hearing.
Teacher, we cannot. You can raise the probability tree.
They are not seeing this thing. Sorry. Okay, it's okay. I was explaining this. I think I should remove this.
So you can erase the probability.
No, I'm using it to explain. I'm using it to explain. I was explaining something here, which I'm going to write. The probability, I'm just reminding you because we covered this in mutual exclusive events. When I write probability of R1 D2 or D1 R2, it means for you to have one red card, it's either when the first one is red followed by green, the first one is red and second is green, or when the first one is green and the second is red. The two cannot occur at the same time. It's either this or that. It means these two are mutually exclusive occurrences. The occurrence of one, when it's either this or that, the two cannot occur at the same time. And remember the definition of mutually exclusive, the additive rule for mutually exclusive events, that when you have A of B, which are mutually exclusive, the probability of A of B is equal to the sum of those individual probabilities. That's why we are going to add these. I'm explaining the reason why we are going to add. And in most cases, we generalize and say, if more than one end result satisfies a given requirement, to get the probability of that end result satisfies a given requirement, sum up those probabilities. The probability that you have only one red card is satisfied, okay. Having one red card is satisfied by these two. Therefore, get the sum of these two probabilities. So let us work out that. We don't need to demonstrate this, to illustrate this. We just present our work in this form. Since we have already defined X, I'm just going to compute and the probability of having only one red card will be the probability of red followed by the green plus the probability of green followed by red. Then getting this probability is just multiply the probabilities along the branches. 3 out of 5 times 2 out of 4 plus 2 out of 5 times 3 out of 4. And finally, you end up, I'm not going to reduce it, but you end up with 12 out of 20. In the non-reduced form. And finally, since you are picking two cards, you can have 0 red card, you can have 1 red card, or 2 red cards. This one I'm going to write it here. The probability in the same way that X is equal to 2. I'm sure you can see that up there. Oh, You see? Yeah, you are not able to sit down here. The probability to have only one red card is the sum of these two probabilities. Write very fast and proceed. And lastly, have you finished this? Let me ask one person.
No.
Not yet. Okay. Sorry. Gracie, for your finished. Next time we shall use bigger board. Try to be fast, please. This time you can decide.
So it's okay.
Okay, very good. Lastly, the probability of x equal to, remember, you know the meaning of x, capital X. The number of red cards being 2, the probability the number of red cards is 2. This is why we have 2 red cards, red followed by red. Just get the probability that the first one is red and second is red, which is going to be equal to multiply the probabilities along these branches. 3 out of 5 times 2 out of 4, giving us, let me just leave it in that form. Just leave it in that form. Okay, now that I can now remove the tree. And remove the tree. That tree, that particular tree, we just use it to list all the possible outcomes of this experiment. You should know the meaning of an experiment in math. This probability is a probability experiment. Now, can we now end up generate or draw our table showing the values, the possible values that this random variable can take on together with associated probabilities. Okay. We can write it as simply as possible in this form. We may not even close the table. Just a very simple table. Save time. This little just joining at this time. Oh, we are serious. Okay, you can have 0. You're going to give me those probabilities. 1 up to 2. What was this probability? Read from the probability. The first one here. Read from the probability. Be fast.
2 over 2.
2 over 20.
Then the second one.
12 over 20.
Over 20.
That one.
6 over 20.
Very good. Now from the table above, we can be able to state the properties. From the table above, we can state the properties of a discrete probability distribution. From the table above, we can state the properties of a discrete probability distribution. What is the first property here? You know these properties. Property 1. When you look at this table, look at these probabilities and give me the properties of this probability distribution. Sabra, Nakalembe, give me the first property. Sabra. Nasibwa Joan. Nasibwa Joan. This is the way we can roll call people who are dodging. Some of you just see log in and disappear. I've noted with concern that Nasibwa Joan has dodged the lesson.
I'm here, wallahi, teacher, in the
Yes,
lesson.
for me, I can roll call. I was roll calling, by the way. I have my list here. So when you're in the lesson, I mention your name, be actively involved during the lesson. Is that okay?
Yes, teacher.
Yes. Okay, because we are coming to the end of the lesson, next time you get to use. That's how I teach. I want you to be involved in the lesson.
Hey.
Now, the first property, let me mention these properties because we have less time left and we need to complete some work. If I give you, I have to give you some numbers. When you look at these probabilities, they lie between 0, okay, and 1 inclusive. It is possible to have 0 here, but don't we have 12 out of 20, 12 out of 20, all these values you see lie between 0 and 1 inclusive, meaning that they can take on value 0 up to value 1. We don't expect to see a negative value here or a value less than, okay, the value less than 0 is negative, or a value better than 1. You don't expect to see such a value. 2, I want you to add these probabilities, add those probabilities, add, and give me the answer. Add. This plus this, what do you get?
20 out of 20.
Which is 1. Very good. I like people to participate in this. The sum of the probabilities must add up to 1. That's how I write it. For all values of x, all values of small x, for all x. For all the values the random variable can take on, the sum of all the probabilities.
Teacher, we don't know what you've written down there.
Hey, you are not seeing here. Let me write up here. The sum of all values of x. This is small x, by the way, be careful. When you add these probabilities, this plus this plus this, the total. This is true. This applies to all probability distributions. Whether it's a discrete random variable or a continuous random variable, the total. With continuous, we shall get the total by integration. We shall look at that. But for discrete, you get the total by adding. You just add those different probabilities. And all of them must add up to 1. Okay, next example. If I give you exercise, you're ending at 10:30, we have 8 minutes. I don't want to exceed time. My watch, please. We have 8 minutes to time. I don't want to exceed time. I want to stop at exactly 10:30. Have you finished this?
No.
Okay, be fast. But you see that 86. Be fast. Can I remove this?
Yes.
Okay.
Yes.
Okay. And let us look at the next example. Simple example. 2. Can be the third one. Find the whole number in there. Discrete random variable. Discrete random variable x has the following probability. Has the following probability distribution. We have x, and then probability of x. Zero. Find the value. Find the value of k. Then 2. So write that very fast. We'll do one more number. Discrete random variable x has the following probability distribution. Be careful with the capital X and small x. K. Find the value of k. How do you get the value of k?
Teacher, we add all those variables at the bottom and equate them to 1.
That is the Tracy Angela. We add all the probabilities. We add the probabilities and equate to 1. So we have 0.11 plus 0. Meanwhile, add for me because I don't have the calculator here. We add all the probabilities and equate to 1 using the properties of the probability distribution. So what is this when you add this, and that? What value are you getting?
0.7.
0.7.
0.7. So 0.7 plus k equal to 1. What is k? That one you don't need a calculator, can take. Okay, very good. 0.3. Now the next one, we have the value of k, Roman 2, the probability that the random variable takes on values from 1 up to 3. 1 up to 3 we can have 1, 2, or 3. It's either 1 or 2 or 3. Therefore, get the sum of these probabilities. The sum of the probability of the values that the random variable can take on. Get the sum, get the probability of x equal to 1, plus the probability of x equal to 2, plus the probability of x equal to 3. That's space enough? Not enough. Let me write. right here. What was it? 1 up to 3. Three. This one is going to be equal to 0.17 plus 0.29 plus the last one, 0. The value of k was 0.3. What is that answer? What's that probability?
0.76.
0.76.
Very good. 0.76. So now an active class. And let me just give you exercise. Let me just give you this exercise. Let me just give you this exercise. And we call it exercise. Shall continue from here next time. Let me just give you this exercise and then we call it a day. I'll finish. We shall continue from here next Tuesday. Can I remove this and I write the number, the exercise?
Yes, teacher.
Please. Yes, teacher.
Okay, let me write the exercise very fast.
Yes.
Exercise.
Excuse me, teacher.
Yes, please.
Is that negative 1.5?
Negative 15. Negative 15. Negative 15. You add for me this probabilities. Add for me very fast. Find out if they add up to 1. Can you check if those probabilities add up to 1? You check for me.
Teacher, they are.
They add.
Very smart. Now that is the probability. The moment you see not adding to 1, means there's a mistake somewhere. Okay. That is the end. I shall continue from here. I wish you a good day. Wish you a good day.
Same to you, teacher.
Thank you, teacher.
I'll go for the next lesson. Shall continue from there on next Monday. Next Tuesday, same time. God willing. Be careful. COVID is real. All right.
Please.
Yes, please. The lesson ended. What is your? Are you having a question?
No, teacher, it was answered.
It was what?
Teacher, it was not a question. We just couldn't see that.
Then I've finished the lesson. You're not seeing. This is for a bit of x greater than 15. A bit of x is greater than 5 at less than 28. X less than 25. A bit of x less equal to 5. Simple as that. It can't be running out. You are